All right, Algebra 1. Welcome back, guys. Here we go for another chapter, chapter 10 here. We are getting started today. And listen, I know in chapter 9 we had a lot of stuff dealing with polynomials. And what we're doing now is we're going to take some of those equations and that information, and we're going to shift it into a different direction where we are graphing a lot of those equations now. And I understand sometimes students are not fans of graphing, but I'll teach you some tricks throughout this chapter. But right now in section 1, it's just going to be a matter of plugging numbers in and seeing what we get. All right, so first section, section 1, it's all about graphing ax squared plus c. A could be basically any coefficient, and you're going to be getting some information in this section with some charts that will tell you when A is a positive, what that does, when A is a negative, what that does, when it's a fraction, what that does, all that kind of stuff. And then the value of C that you get right there, that's basically going to affect how your whole graph moves. You know, is it going to move up or down? And you'll see what that does there. Okay, so this is a quick breakdown of our last chapter. So I'm just going to zoom in on that right there for you. So that is a little bit of what you just learned, and basically stuff that you can't forget. Okay, so you have to remember all that stuff because we build on it and we move into the new chapter where everything from what you just learned is now going to be built on. All right, and you're trying to keep this structure growing. All right, so let's move into a little bit of the new notes that we're going to have here. So if you see something highlighted, or of course if it says copy, then you're going to need to copy that. Okay, so in these equations you're going to see an x squared. You saw that all in the last section. But what does that tell you? It tells you that it is a quadratic. Okay, so when you hear or see this word quadratic, that means that you must be dealing with an x squared in the equation. All right, now when you have that, so take a look over here. Here's an equation where it just says y equals x squared. That is going to create a graph with the name parabola. That shape that you see right here and right here, that shape is given this name, parabola. Okay, and now what I want to kind of focus in on, I notice we didn't highlight one of these right there, is that if you are dealing with a positive one, notice that in front we would just have a positive 1, then that is going to make a parabola that we call that opening up. Okay, kind of looks like a smiley face. All right, so one of the ways that I describe that is that if you are positive, you smile. All right, then let's look at this one here, a negative 1. So if you are negative, then you frown. Okay, so that opens down if you have a negative coefficient or a negative value in front of the x squared. Okay, so if we slow it down and kind of back it up one step and go back to the top, I'm talking about this value right here. All right, so in front of x squared is a. A is any coefficient. If a is a positive, it makes a smiley face, or an upward facing parabola. If a is a negative, then it makes a downward or frown facing parabola. Okay, all right, so here's some more notes here. Notice this is basically what I just described. This is what that is telling you. The notice when you have a negative, or notice when you have a positive, what that does. All right, now these are some other terms. So I'd like you to copy down this information about quadratic function, standard form. You got that name. I already told you about parabola. This is important to copy down right here. All right, so take the time to copy that into your notes. And now what I'd like you to notice is what this does to the shape of a parabola. If a is a positive, like we already talked about, it's going to open up. All right, if a is a negative, it's going to open down. But then when you incorporate that value of c, that constant value right here, that's a constant, it's going to move your graph up or down. If it is plus c, and that's a positive, it's plus, it's going to move your graph up. If this is minus c, it's going to move your graph down. Okay, so all the graphs should normally start right there at the origin, that's 0, 0. But if it says plus c, then it's going to take that starting point and move it up. If it says minus c, it's going to take that starting point and move it down. Okay. All right, remember, any of these parts on the videos, you could pause it, rewind it, listen to that again. All right, let's do some example problems so you can see what these look like when you graph them. So I'm going to start by recommending that we really just need to use 3 values. All right, let's get 3 values that we are going to plug in every single time into these equations, and then we're just going to connect those 3 dots to create the parabola shape. Okay? All right, so those 3 values that we're going to use every single time, let's just keep it really, really simple here, right? Let's use -1, 0, and +1. Those are the 3 simplest values that we could use every single time, right there. -1, 0, and +1. All right, so when we plug those values in, we're plugging them in to x. The answers that we get out are the value of y. You put x and y together, and that is a point that you're going to plot on the graph. All right, so plug in -1, you have -4, then -1 squared. Then we're going to plug in a 0, which, by the way, that's nice because that's always going to work out to be 0. And then we're going to plug in a +1. All right. Now, something that you should remember, if you forgot, anytime you square a number, this right here, remember, square a number, it will always become a positive. So what that means is when we're focusing on this one right here, -1 squared makes +1. +1 times -4 makes -4. So now we have a point, -1, -4. 0 squared is 0. 0 times -4 is 0. So that means we have a point of 0, 0. Then same thing you're going to notice. 1 squared is still 1. And 1 times -4 is -4. So we have a point of 1, -4. You should notice these guys are the same except for what I plugged in. But notice the answer that came out, that's the same. And that should be because, remember, a parabola makes a perfect symmetrical shape. Like if you fold it in half, it will perfectly fold over onto itself. All right, so let's graph this. Let's change our color. So we got a nice easy point right there at 0, 0. Then we have a point at -1, -4. -1, 1, 2, 3, 4. Then +1, 1, 2, 3, 4. So this is a downward opening parabola. Okay. Oh, that's not looking quite right. Let's go with the non-iPad help here this time. There we go. That's good. All right. So that is our graph for -4x squared. All right. Next one. Plugging in those same values of -1, 0, and +1. All right. So you get -1. Notice that I'm putting it into parentheses. You should do the same thing. It's a good habit to get into, just so that you understand it's that whole value, -1, the whole value squared, +2, 0 squared, +2, and 1 squared, +2. All right, -1 squared is 1, +2 is 3. 0 squared is 0, plus 2 is 2. And 1 squared is 1, plus 2, again, is 3. So what we have here is negative 1, comma 3, 0, comma 2, and 1, comma, nope, 3. Sorry about that. All right, so let's graph those points that we just got there. We have a 0, comma 2. That means that this is our constant value, telling us that instead of being at 0, 0, we're going to go up 2. We have a 0, comma 2. That point is right there. Then we have a negative 1, comma 3, and a positive 1, comma 3. And let's connect those dots right there. All right, there's our graph for the x squared plus 2. All right, let's do another one. This time we have a negative 3 right here, but we also have a 3 coefficient right here. Okay? All right, so plugging in negative 1, 0, and positive 1. One thing you should be able to tell, you're going to get into this good habit, is anytime you plug 0 in right there, 0 squared is 0. 0 times 3 is 0. So that negative 3 value is going to take our starting point from the origin and drop it down 3 times. So it's actually going to be right there. All right, so let's save a little bit of space. 1, 2, 3. Let's drop down, put our first dot. Then we'll take the time to plug in 1 and negative 1. But here's another hint that you should see here, right? If I plug in negative 1 or positive 1, when I square it, they will both be 1. So that means all I have to really do is plug in one of those, because the answer will be the same for each of them. Meaning if I plug in negative 1 or positive 1, the answer will still be the same. So let's just save even more space and plug in 1. Square it, subtract 3. So 1 squared is 1. 1 times 3 is 3. 3 minus 3 equals 0. So that means I'm going to have a point at 1, comma 0. I'm also going to have a point at negative 1, comma 0. And I already graphed one of the points. Okay, so let's plot those in there. We go positive 1 at 0, negative 1 at 0. So there is the graph right there. Okay, so now you're going to get in this habit. You're going to understand a little bit more, save you time, save you some space. All right, last one. Let's use that same train of thought. I know immediately you're looking at this fraction and thinking there's no way. It's okay. All right, we'll figure this out together. Fractions don't need to be that scary, but keep working. So one of the things that we talked about, let's plug 0 in and square it. It's 0. 0 times 3/4 is 0. And 0 minus 2 is just going to be that, negative 2. So we know we're going to have a point that drops down 2 times, and it's right there at negative 2. Notice on the y-axis. Okay, now let's save ourselves some more time. Let's just plug in 1 and work this out. So if we plug in 3/4 multiplied by 1 squared minus 2, then we're looking at 1 squared is 1. 1 times 3/4 is 3/4. So yes, I know you're dealing with a fraction. 3/4 minus 2. But we need a common denominator. Okay, so 2/1, that's not a common denominator. What do I have to do? I have to multiply both sides by 4. So that means I'm really dealing with 8/4. So this is our real fraction now. 3 minus 8 giving us negative 5/4. And then what did we do? We plugged in a 1. So 1 comma negative 5/4. This is a bit of an estimate, all right? 5 over 4 means it's a little bigger than 1. Okay, so a negative 5 over 4 means it's a little bigger than negative 1. So let's graph this. We're going to have a 1, and then we're going to go down a little bit more than 1, right there. Then we're going to have a negative 1, and we're going to go down a little bit more than 1. Okay, so meaning I have 1, and then I went a little bit more. I went down 1, then a little bit more. That's where this 5 over 4 is getting used. Okay, it's going to make a slightly wider parabola shape. Okay, there you go. Our 4 example problems. If you guys have questions, please feel free. Bring those questions to class. We'll work them all out together. If you need to take the extra time, rewind a little bit of the video, watch a little bit more again, review. See you guys in the next one.